Welcome back, students. In this video, we're going to cover Module 8, Topics 3 and 4. Similar triangles. This is going to be AA, SS, and SAS Similarity. So angle, angle, side, 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 and side, angle, side similarity. This is page 9 of the Module 8 packet. Got the warm-up here. Excuse me. Fill in the blank. The corresponding angles of similar triangles are always blank. All right, so think back to the last topic or two. I believe we've touched on it in both. Probably more the topic 2, though. So to be similar, you have to be able to map one onto the other with a dilation and/or dilation and transformation. Remember, your translations, your reflections, all those things, we move a shape, we don't change its size, so the angles and sides stay the same. Now when we dilate, we talked about, so the triangle gets bigger, the angles stay the same, the sides get bigger. So the angles are, so for similar triangles, just like, as I'm talking about, because that's what makes them similar, is you can dilate, you can do things to put them onto themselves. Hang on 1 second. Okay, sorry. Somebody came to my door and it kind of threw me off. So back to number 1. Corresponding angles of similar triangles are always congruent or proportional. Well, the angles are always congruent. Because remember, the angles don't change, the sides do. The size of the, so here where it says the sides, those are proportional, but the angles are congruent. Okay. Number 3. I'm going to go ahead and scooch down while I'm here. All right, so number 3, determine if the polygon is similar or not similar. So now I had to go ahead and write these in because they're so small. It's A, B, let's see, A, B, C, D is down here, and then it's X, W, X, Y, Z. So you see what corresponds here, 45 and 45, 105, 105, 120, 90, 90. So all the angles are congruent, as we talked about for number 1 here. Now, are the sides proportional? So we're just going to pick 2 of them. So we'll just start here. These figures are the same, so we don't have to kind of guess. It's just this slope here, this slope here. So 15 over 150. 5 goes into 15 3 times. It goes into 150 30 times, which also breaks down to 1 over 10. Okay, so let's go this here, 4 and 40. That should be fairly easy because it's 1/10. So both of these are 1/10, so the answer is yes for number 1. Excuse me. All right, number 4. I said number 1. Number 3 was yes. Number 4. So we have our triangles. Our angles that are corresponding, and our other angles here. So we would have EF. Let's see, EF, which is a blank and a pink, to ML, which is a blank and a pink. Let's see. All right, so EF to ML. That's 15 over 25. 5 goes into 15 3 times. It goes into 25 5 times. So let's see, we got pink and brown, so LN. Well, it would be EF. We got to start over here. You guys are right. FG. We have to start where we started the first time. Both times the same. So LN. So we have FG's 18. LN is 30. So let's see why we were practicing greatest common factors. All right, so I told you guys 3 is always a good guess. The 3 goes into 18 6 times. 3 goes into 30 10 times. Obviously, we can break this down more. So 2 goes into 6 3 times. It goes into 10 5 times. So these two are yes. All right, let's scooch down the page. Talk about similar triangles. AA similarity, or angle. Excuse me. All right, so postulates and theorems of Euclidean geometry can be used to prove that two polygons are similar. In similar triangles, all of the corresponding angles are congruent. So we've talked about that a couple of times. And all of the corresponding sides are proportional. We've now talked about that a couple of times. Must be important. So, however, you don't need to show that all the criteria are met to show that the two triangles are similar. Just like before, there are 6, 3 sides, 3 angles. So 6 corresponding parts between triangles. And we only need 3 to prove that they're congruent. And see, and in some cases 2. So like here, we're going to talk about angle. Let's see, hold on. I think I skipped part of this. Yeah, I skipped the last sentence. So, no. Angle similarity is one of several shortcuts. So yeah, postulate 8.1. Angle, or AA similarity. So just like congruence, this is similarity, same thing. All right, if 2 angles of one triangle are congruent to 2 angles of another triangle, then those triangles are similar. So 2 angles, but yeah, congruent. So right here, these 2 would be similar because of they had the angle. Okay, let's move our camera. Gonna leave that so we can see it, because that angle is kind of important. All right. Using AA similarity postulate. Number 1, determine whether the triangles are similar. If so, why? And explain your reasoning. All right, so let's see. We've got a little fill in the blank. All right, so it says yes. They're telling us they are. L is congruent to L, so this guy is congruent to, this guy by, so if I look in the mirror, I see my reflection, or it's reflective. Hopefully you guys are getting ahead of me on this, and it's a reflexive property though. All right, so got that. So there's an angle. And then LPQ, so LPQ is congruent to LJQ by the, so notice we have 2 parallel lines. Excuse me. Sorry. So both of these lines are parallel. I want to point that out. But these angles are congruent because they're corresponding angles. So those are corresponding angles, and that's what makes these guys. And let me, oops. There we go. All right, number 2. Determine whether triangles are similar. Explain your reasoning. All right, so both of these guys have a box. Hopefully you guys know by now the box means 90 degrees. So we have at least one angle that is congruent. Let's just go ahead and put that angle C is congruent to angle D. So we need one more. All right, so if these guys are 90, that means these guys have to be 90 together. So let's just look. So 90 minus 44 is 46. So that makes angle A 46. And over here, 90 minus 47, well, that's 43. So that makes G 43. So So angle A is not equal to angle G, and angle B, is not equal or not congruent to angle F. So it's no. Now, over here, they gave us the yes, so I was looking for my yes, but there it is. So yeah, these guys are not similar. Let me just say not. In the reasoning. So we only have one angle. This is 43. 43 is neither one of these, and this one's 47, and that's neither one of these. So none of those angles are congruent, just the 90 degree. Okay, let's flip over. Page 10. Reposition. All right. Find the missing value in similar triangles. We've got an angle and an angle. So we're going to find the value of x. So how do we know these guys are similar? We would have to put them in proportion to see. We only have one angle, but is there anything else? I'm just going to give you a second. Well, for those of y'all that knew this, congrats. If you didn't, it's okay. So right here, this right here, these lines intersect that make vertical angles. That makes this and this congruent. Okay, so we have two angles. So we have AA similarity. So now, it's a green-brown, this guy, 3 over green-brown, x equals brown blank, because we got to go left both times, right? But you know, we start the same side and we go top, bottom, top, bottom, or if we did top, you know, either way, you guys get it. So this side was 5, this side's 3. So cross multiply. I'm gonna do this for a little bit, and hopefully you guys will remember this, but I like to do this for a little bit. So x and 5 make 5x. 3 and 3 make 9. Divide both sides by 5 so we can find x. 9/5 is 1.8. So x is 1.8. All right, number 6. A painter needs to determine the height of a building to estimate the amount of paint she will need. If she is 5 feet tall and she casts a 3.5-foot shadow at the same time the building casts a 25-foot shadow, how tall is the building to the nearest 10? I know you guys hate word problems, so we're going to take this slow. So a painter, so she's 5 foot tall, and her shadow is 3.5 foot tall. So here is she. She is 5 foot tall, and her shadow goes out this way is 3.5 feet. She's 5 feet. Okay, so we're just going to go ahead and draw, and she and the ground are going to make a right angle, because when we stand up straight, we're perpendicular to the earth. All right. Now, the building, so let's just make BLDG for building. It's going to be taller than her and cast a longer shadow. So, at the same time, the building cast a 25-foot shadow. So this is 25 feet down here. We want to know X. We want to know how tall that building is. Okay, so we're going to take and make our proportion and then solve for X. X is going to be the height of the building. How tall is the building? So she's 5 feet tall. We don't know how tall the building is. Her shadow is 3.5 feet. The building cast a 25-foot shadow. Wish I had more colors on this dang crazy green. Wasn't beat up. All right, so cross multiply. Cross multiply. All right, so x times 3.5 is 3.5x. 5 times 25 is 125. Divide both sides by 3.5, so we get x by itself. 125 divided by 3.5 is 35.7 feet. So the building is 35.7 feet. We can calculate that based on the girl shadow, the painter shadow, and the building shadow. All right. Oh, and by the way, so on here, our second angle, the reason these angles are going to be congruent is the sun makes that shadow. It's behind you, so these two angles will be congruent. Just want to mention that. All right, number 7. DeMarco is teaching Tay how to play handball. Tay prefers to return the ball on a serve when the bounce is a height of 42 inches. Okay, so 42 inches. All right, A. When DeMarco serves the ball, where should he aim for the ball to hit the front wall to ensure that it bounces at the short line up to Tay, standing 11 feet behind the short line? Assume the angles formed by the path of the bouncing ball are congruent. So, whoo-wee. All right. I'm going to kind of draw this in because it looks a little better. So 42 inches, that's how high he wants to serve it. It's going to bounce here. And then, my drawing's terrible. So we're trying to figure out, this is the 25 feet. 11 feet is the difference between these guys. So I'm just going to put this 11 feet. And then the front of this line is from the wall to the back of the short line is 25 feet. This is 11 feet. 42 inches here. I'm just going to write 42. Now, 42 inches, as we're dealing in feet and feet here. So we got a little problem. 42 inches is also 3.5 feet. So we have this height, and then so the whole wall is 16 feet from here, from top to bottom. We are looking for X, which is going to be the height, and I know that looks weird, but that's the height that the ball is going to hit so that it bounces where we need it to bounce. We have two triangles, so we're going to, X is the height. I put X marks the spot here, but X is the height. So our ratio is going to be height over height. Let's see, and then length over length. So just bear with me. I'm going to change pens here. So this guy's X. This guy's 3.5. So we're going to go 3.5. So that's where he's at. The height we're looking for is X. He's 11 feet away from the line here. We're wanting it to bounce 25 feet, which is over the short line. So 3.5 foot serve, 11 foot from the short line. X is the height we're looking for here, 25 feet from the short line. I know this is, I hate this question. Okay, cross multiply. X times 11 is 11x. 25 times 3.5 is 87.5. We divide both sides by 11. And X is 7.95 feet. So, he wants to aim for about 8 foot off the ground for it to hit where he wants it to hit. Or come back to and hit right here. I don't know handball. Sorry. So, let's scooch down to the bottom here. Talk about these notes before we flip over to the next page. So, similar triangles, SSS and SAS. So, side, side, side. and side angle side. We've already talked about AA or angle angle. So theorem 8.4, side 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 similarity. If the corresponding side lengths of two triangles are proportional, so side lengths proportional, then the triangles are similar. And it's because we have the angles if they're similar. So two sides here. So let's see. Let me work that there. Let me just do the color thing the best I can from the last video. So JK, so JK and MP. So I'm going to make them the same color. Just let you know it's going to get sketchy when we get to the green here. All right, next one, KL. Let's do LJ. I got to go short with this. LJ and QM. All right, last one. If this will look different enough. Well, yeah, it'll work. All right, so KL, PM. I'm sorry, PQ. I'm looking at the M. So that's how we are. Those are in proportion, and I just put them. I put the corresponding parts in the same color. All right, flip it over, page 11. We got 11 and a little bit on 12. So just a moment here. Scooch. All right, theorem 8.5. SAS or side angle side similarity. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides on another triangle, and the included angles are congruent, then the triangles are similar. So in this case, I'm just going to highlight the angle here. So we got an angle. So angle, angle, RS, and XY. And ST, YZ. Okay. So we have a side and an angle and the side. The angle's kind of hard to see because I made it yellow. Hopefully you guys can see that though. All right, number 8. Oops. Determine whether the triangles are similar. Explain your reasoning. All right, so notice this guy's flipped upside down. So here, these two are going to go together. This is this side, this side. You know, you got to eyeball it sometimes. I told you guys you go with the lettering, and that works. In this case, there is no lettering, so you have to kind of look at the triangles and see how they would be proportioned, and then it'll work or it won't. You know, spoiler alert, this is side, side, side. So, or no, I'm sorry, this is, I think we're looking for two sides, so we'll see. So let's just go with the green. We'll go small over big this time. So 9 over 16. Let's see which 3 goes into 9 3 times. No. Sorry, what am I doing? I think, did I do that wrong? Hang on, I think I got the wrong sides. I had PQ and JK. Well, that's right. Oh, PQ and JK would be these two. Well, I still say, let me think. Let me look at this. Hold on. Okay, yeah, I can see where we actually, we should have flip-flopped. we'll do this. Let's say 9 and 12 go together. And then we'll turn this guy green. Sorry, okay. So it's going to be 9 over 12, which 3 goes into 9 3 times, 3 goes into 12 4 times. So let's look at, actually it wasn't, no, 9 over 12. 9, oh, this 12, this 9, this, okay. I was like, wait a dang minute. All right, so we got 12 over 16. 12, let's see, 4 goes into 12 3 times, 4 goes into 16 4 times. All right, let's try the last. So 6 over 8. 2 goes into 6 3 times, 2 goes into 8 4 times. So yes. And it's because the sides are proportional. Or in this case, it'd be, well, you can't say side angle side because we don't know about the angles. So actually be side side side, but let's do that. How about that? Okay. So let's see. We got this side with this side. This side with this side. And then that puts the outer two together. So we have 10 over 20. 10 goes into 10 one time, into 20 two times. Then we have 11 over 22. 11 goes into 11 one time, into 22 two times. So yes. And these are those are congruent. So we have a side, an angle, and a side. All right. Just a moment to scooch down the page. Gonna look at 10 and 11. Just mark a couple of things here. We've got some parallel lines. If those are parallel, that means those angles are congruent, is what that means. So that makes these in proportion. And these would be in proportion. So let's see. So this is going to go slightly different because we're going to go length to total length. So it would be this length to, it would be 5 to 5 plus 3 because you want the whole length. And then this would be 6 to 6 plus 3 and 3/5. Let's see, which it's easier to use this one, and we want to see what this is because this to the total is going to be the same as this to the total, I think, or this to this, excuse me. It's the same proportion. All the sides are the same proportion. So this was 5 over 8, this right here. Then we're going to take x over x plus 2 and 1/4. I'm going to go ahead and make it a fraction. 1/4 is a quarter, or 2.25. Now we're going to cross multiply. Just, yeah, see, old green here is just about half. All right, so 8 times x, 8x, equals 5 times x is 5x plus 5 times 5.2, I'm sorry, 2.25 is 11.25. All right, let's get the x's by themselves, the x by itself. 8x minus 3x is 5x, and we have 11.25 over here. Divide by 3, divide by 3, x, let's see, where did I put it? X equals 3.75. Now, they wanted QN, so X, which was QN, was 3.75. Now, PO is X plus 2.25, so PO is 3.75 plus 2.25, so you add those together and you get 6. Put PO right here. All right, let's do the other side here. Then we flip over and grab the last page. All right, so I'm just going to do this. So we see the S there with the mark. So these two are in proportion. That's going to put this guy and this guy in proportion. Because these are intersecting lines. You go here to here, here to here. That's how you do it. So let me see. We're just going to say 4 over 5. Since we started here, we go here, x plus 6 over 2x plus 6. And now we're going to cross multiply. I'm just going to do it like this. These two together. And these two. You know it's circled. I'm not going to keep doing that. So, we got to distribute these out. So 5 times x, it's 5x, plus 5 times 6 is 30. The other side, 4 times 2x is 8x, plus 4 times 6 is 24. All right, let's go ahead and put the x's on one side here. So we'll go 5x. Actually, you know what? Let's just do this. We're gonna do it all in one step. So I'm gonna subtract 24 from both sides and subtract 5x from both sides because can't do that. Stupid. That would empty one side. So I gotta subtract. Wait. What am I doing? Yeah, that's right. Minus 24. God. Okay. 5x's cancel out. 30 minus 24 is 6. 8x minus 5x is 3x, and the 24's cancel out. So now we have 6 equals 3x. Divide both sides by 3. X equals 3. Okay? Now, they want WR and RT. WR equals x plus 6, which is x is 3, so 3 plus 6. So WR is 9. And then RT is 2x plus 6, which is 2 times x, which is 3, plus 6. So 2 times 3 is 6. 6 plus 6 is 12. Okay? All right. Let's flip over at this last page. I know we can do it. I'm going to zoom out because this thing's kind of, got 2 problems on the back here. Page 12, last of the topic. What is this? Topic 3 and 4. It was a combo. All right, so use similar triangles to solve problems. Architectural design. Julia is designing an A-frame house. So here's your A-frame house in front of us. The entire house will be 40 feet tall. And the base of the house, so hang on, 40 feet tall. And that is from here to here, okay? I know it's not a straight line. My apologies. The base of the house will be 60 feet long. So 60 feet, and that's all the way. Yeah, that's the bottom. Okay. Let's see. She'll have a balcony built a second floor balcony along the front of the house, 15 feet above the ground. So this little balcony here, I'm just going to do this, is our balcony is 15 feet off the ground. So now we know how this length and this length. Left side of the house will be 50 feet, so this side's 50. And a balcony will intersect the side 18.75. Okay, so there's 18.75 feet from here to here, which tells us how long that is. All right. The peak of the house is directly above the midpoints. Let's see, calculate the total length of the balcony. Okay. So, it may be easier to draw two triangles over here. This is, we'll call this A, E, what is that? This is A, C, E, is this, oh, this is D, sorry. D here. Oh, the D's the midpoint, okay, B here. So A, B, C, well, what are these letters? I can't. Oh, yeah, I guess we're just looking at this. So, yeah, A, D, E. And then the bottom one would be A, B, C. So, this guy and this guy. So, let's get some measurements here. So, the whole side was 50. And the house, I knew I drew it all the way across, but it's actually just here. So that's 50, that's 60. This side's 40. So now let's do some subtracting. We're looking for X. We're looking for the length of the balcony. So if it was 40 feet from here to here, and this was 15, 40 minus 15 is 25. All right, and if this was 50 and this was 18.75, 50 minus 18.75. Let's see. So right here is 11.25. No, 31. Good Lord. 31.25. So now we have something to do here. So now we're trying to find X. So if everything is in proportion, I'm going to switch pins. So we have, let's see. All right. So I'm looking here. This was 60 all the way across. This is half. So technically this is 30. So if 60 all the way across, 60 divided by 2 is 30 feet. So just so we see that and we know what we're talking about. So our proportions are going to be, we'll just say X to 30. And then, let's see. So X to 30, and then we can go 25 to 40. All right, then we'll cross multiply just these guys and these guys. So 40 times X is 40X. 30 times 25, give me just a moment. 750. Divide both sides by 40. X equals 18.75. And that's going to be feet. And that is how long. Oh, wait. Now, X is going to be 18.75. Remember, this line in the middle is halfway. So 18.75 would be this plus this. So the whole balcony is going to be 2x, or 18.75 times 2, which is 37.5 feet. Okay, yeah, I'm sorry. It's really hard to see the lettering but yeah, it's half. This is the half of the triangle we're dealing with, but there is another half. Because it was 60 feet the whole way across. I guess the balcony. No, the balcony's all the way across, but I guess the midpoints here is how we're supposed to know that. Anyway, all right, let's finish this up. Number 13. Let me give a little room down here. All right, Justin's playing tennis. He stands 12 feet away from the net, which is 3 feet tall. The ball is served at a height of 7.5 feet. He thinks the ball is going to travel 21.4 feet before it hits the ground 8 feet above the net on the opposite side. This thing is nuts. Okay. So, and it's not even, didn't even finish giving us the question. So, give me just a second to draw this crazy triangle. So, give me just a second. Yeah, all right, hang on, hold on. Gonna be right because we're talking about being on the ground, but hold on. The way it looks the best. So we have a right triangle because this guy throwing it and the ground make a right angle. And the net is here. It's a 3-foot net. It is 12 feet from him to the net, and it's 8 feet from where this ball is going to land. He thinks that it travels a total of 21.4 feet. It doesn't really ask. The question kind of craps out there, but what we're really looking for is this length from here to here. How far? So if it went 24 point, let's see, travels about 21.4 feet before it hits the ground. I think we're looking for the distance here. I said it's very, very strange. So we're going to use 8. So 8 to the whole length. So 8 over 20 because it's 8 plus 12. Okay. That's where we get the 20. To x, so this one over 21.4. Then we're going to cross multiply. So all right, so 20 times x is 20x, and 8 times 21.4 is 171.2. We divide both sides by 20, and x is going to equal 8.6 feet. Like I said, sorry, this question, I will be deleting it from the packet, but it's there now. We'll work it. Hopefully that wasn't too terribly confusing. If you got any questions, let me know in class. Otherwise, till next time, have a great night.